everyone, welcome to my channel Coding Care. So by looking this slide, you would have know like I'll explain Kafka, right? So wait, everyone know what is Kafka and why Kafka, but before the Kafka, like how Kafka came and what's the internal of the Kafka, also how the different company like Netflix, Uber and LinkedIn so handle the real time data and millions of processing per second, how it works. So in this first episode I'll explain all these things about the Kafka, and by end of this video you will know why Kafka is called distributed streaming platform and where you can use it in your own application. So if you are a backend developer or a data engineer or just curious about the real-time data processing, make sure to watch till the end and subscribe so you do not miss upcoming videos. Let's get started without delay. So what is Kafka and why Kafka and what is messaging system? So you know that Kafka is a message broker architecture and it is originated from the LinkedIn. The Kafka has written using the Scala and Java languages. But wait, first of all, we have to understand why Kafka. Okay, for example, let's say I have different application. Like suppose this is my one application, and this is one more application. Okay, this is one more application, and suppose this is front end application, front end, and this is my, let's say, chart server, and this is Hadoop. Okay, and some other application also there. For example, so I just copy this one. Okay, so this is my, let's say, database server, and let's say this is real time data processing, and let's say this is some data warehouse. Okay, suppose here my front end need data from different application, like from database server, also real time data and data warehouse. So what I will do, so here front end application will connect to database server to fetching the data. Again the front end server will connect to real time data processing to fetching the data. Again the front end server will connect to data warehouse, right? So here each of the application has different specification. So based on the specification I have to write the logic and fetching the data. Okay, and the chart server also need data. So what he will do, he will go to the database server and he will go to the here to real time data processing, and here also will go to the data warehouse. Okay, and Hadoop also similar kind of thing. It needs the data from here and from, so from here and from here. If we properly observe here, every application is talking to every application. Okay, so this will be mess up, right? So it is tightly coupled with this server. So to overcome these problems, what we can do, remove all these things. Okay, and suppose I need data, right, from, suppose this front end need data from three different services and chart server needs data from three different services. Okay, so do one thing, instead of calling to each and every application, let's call one application. Like here this one I can say this is a public repository. Okay, so just think that it's a public repository where all these application will share the data to different application, right? So instead of sharing each of these application, they will share the data to this public repository. Okay, so it will publish here, and this one will publish to here. And these application like front end application, chat server and Hadoop, initially these application talked with different application to fetching the data. So instead of calling different application, they just go to this public repository and fetch the data. So whoever wants the data, it will go here and read the data, and whoever sends the data, he just send to this public repository. This public repository is nothing but messaging system. Messaging system. So, in this slide, I said what is messaging system. Now everyone is clear, right? So what is messaging system? So messaging system is nothing but a common area where we can store or where we can persist the data. Okay, and everyone can send the data to the messaging system, and anyone can fetch the data from the messaging system. Now there are two different messaging system is there. Okay, there are two messaging system is there. What is that two messaging system? One is point to point messaging system. One is point to point messaging system, and second is pub/sub model. Okay, so what is point to point messaging system and what is pub/sub model? Pub/sub is nothing but publisher and subscriber model. Let's explain what is point to point first. Suppose this is a sender and he will send the data, and one receiver is there, he will receive the data, receiver, and he will receives the data, right? Now, so sender will send the data to where? In messaging system, right? So I am explaining the point to point here. Let's say this is, so here let's say this one is messaging system. Okay, so here the sender will send the data to messaging system, and the receiver will receives the data from the messaging system. Here in point to point architecture, messages are persisted into a queue. So this is one queue, and all the messages persisted in a queue. So queue is nothing but first in first out, right? But here problem is only one consumer or only one receiver will receive the message. Suppose I am a sender, I am sending some message like M1, let's say message M1 and M2, then M3, then M4. Let's say this message 1 is already received by one receiver or one consumer. Once the receiver or consumer will consume this M1 message, now the M1 message will be deleted from the queue system or messaging system. So this is the biggest problem in point to point messaging system. Okay, so here imagine a call center. Okay, so if one customer care will be there, then burden of the customer care will be increased, right? So how to solve this one? So this is the biggest problem in point to point system. To overcome these problems, pub/sub model came. So what is pub/sub model? So similar kind of thing, just copy this one and paste it here. Here sender will send the data, or I can say this is a publisher. Okay, publisher will publish the data to the messaging system, and there are different consumer is there or different receiver is there. Let's say I'm saying consumer. Okay, so this is one consumer, and this is one consumer, this is one more consumer, and this is one more consumer. There are three consumer is there, consumer 1 and consumer 2, and consumer 3. There are 3 different consumer is there, and this consumer, okay, so there are 3 different consumer is there, then one message can consume by different consumer. Suppose here 4 messages is there, and here 4 messages is there. Now publisher publish this message m1 m2 m3 and m4. Now the consumer consumes the m1 message, and once it will be delivered, it will not be deleted. In point to point system, what happened? Once this m1 message will be delivered, this message will be deleted, right? But here it will not be deleted because multiple consumer can consume the message. So the consumer 2 can also be consume m1 message, so that's why it will not be deleted. Okay, this is called pops up model. I hope everyone has understood now. Now in point to point, the example, like we can say this is JMS, and JMS is nothing but Java messaging services, and something like Rabbit MQ. Rabbit MQ. This is the example of point to point system, messaging system, and pops up model is the Kafka. Now we learn what is messaging system, and there are 2 messaging system. One is point to point, one is pops up model. Now Kafka is part of the pops up model. Now how the Kafka architecture looks like. So here is the image. So this is nothing but different producer, and this is nothing but different consumers. And producer can be a front end, can be a services, can be a proxies, adapter, anything. And the consumer also similar kind of thing, different type of application. And producer will produce the message, and consumer will consume the message, and the producer will produce the message to the Kafka broker. So I'll explain what is Kafka cluster. All this Kafka broker is part of the Kafka cluster, and it is managed by Zookeeper. So I'll explain everything, what is Zookeeper, what is Kafka cluster, what is Kafka broker. So this is an overview of the Kafka architecture. In the next video, I'll explain how we can install Kafka, and how we can run the Kafka server, and how we can publish the message, and how we can consume the message. Then I'll cover each and every part of the Kafka, like Kafka broker. Inside Kafka broker, different terminology is there, like Kafka topic, and how the message is persisted into Kafka topic, what is the partition, what is offset, everything, how the data is serializing, how it is deserialized, everything I'll explain in next video. Please subscribe my channel and share more and more, so that you can update whenever I'll upload the new video. Hey everyone, welcome to the next video of my Kafka series. So in this video I'll explain how we can install Kafka, how to start Zookeeper, how to start Kafka, and how we can create topic, and how we can publish the message to a topic, and how we can consume the message from topic. First of all, we have to understand how we can install the Kafka in our system. Go to the browser. So this is the site you can download from here. I have given the link in description section. You can download from there also. So there are different version is there, you can download from here. So do not download source code. So here this binary downloads is there, you can download this one. So I have already downloaded in my system, just cancel this one. And yeah, this is the Kafka, and this is the folder I have downloaded. After downloaded, you have to extract this folder. First of all, I have to share, like before running the Kafka, first we have to run the Zookeeper, because Zookeeper will maintain all these things, right? First we have to run the Zookeeper, then we'll run the Kafka. So go to this diagram. Here publisher will publish the message into the messaging system. Messaging system is nothing but Kafka, right? And the consumer will consume the message. So inside Kafka, like first we have to run the Zookeeper, and then we will run the Kafka server. Then after running the Kafka server, I have to publish the message into the messaging system, I mean Kafka. So where it will store? So first of all, we have to create the topic. So let's say, so this is an topic. Here our message will be store. This is the topic. And whenever the publisher will publish the message, and the message will go to here inside topic, and the consumer will consumes the message from this topic. Okay, so this is the consumer will consume the message from the topic, but inside topic there are some partition is there, like this is one partition, this is one more partition, and this is one more partition, and there are different partition is there, like we can create multiple partition inside topic, and the data or the our message will store inside this partition. Let's say this is partition 1, partition 1, and this is partition 2, and this is partition 3. So this is the process we can implement now. So first let's run how we can run Zookeeper. So this is the command you can run this one. So I'm just opening the terminal, or just go here in Kafka, and here we can open the terminal. So basically inside this Kafka folder, one bin folder is there. Inside this folder, Zookeeper service start.sh file is there. I'll run this sh file. If you are using Windows machine, then inside Windows machine also same file is there, same bat file. So this is the Zookeeper start server start.bat file. So I am using Mac operating system, that's why I'll use this one. Okay, just go to here in terminal. So I'll paste this one. So this is the sh file inside bin folder, and this is the Zookeeper properties file which is available inside config properties. So if you go to here in config properties, then here Zookeeper.properties file is there. So similar kind of thing we have to pass. So here instead of bin slash this one, in your cases if you are using window, then bin slash window, then try this one. Okay, just run this one. Yeah, now my Zookeeper has started. Now I'll start the Kafka. So I'll go to the here, I'll create open one more terminal in the same folder. Here I'll run the Kafka, right? So this is the command, you can run this one. Okay, hit enter. Yeah, now Kafka has started, and the Kafka has started on which port number? This is, yeah, this is 9092. Okay, this 9092 port number Kafka has started. Now I have opened two terminal. So here I opened two terminal. So in one terminal I have run our Zookeeper, and in another terminal I have run the Kafka server. Now I'll open one more terminal here, and terminal, and here what I'll do, I'll create the topic. Now we have to understand how to create topic, because I said this image, like publisher will publish the message to the topic and consumer will consume the message from the topic. So before publishing the message, first we have to create the topic so that I can push or I can publish the message to here. Then how we can create the topic? So if you'll go here in inside Kafka in bin folder, something Kafka topics is there. So yeah, this one. So Kafka topics.sh, using this cell we can create the topic. So let's create the topic. So here just type bin slash Kafka hyphen topic dot sh. Then I have to create the topic, right? To create the topic, one property called hyphen hyphen create. So using this create, we can create the topic. After hyphen hyphen create, give one space, then give some topic name, like let's say this is my log. So after creating the topic, we have to mention where our Kafka broker is running. I mean where the Kafka server is running. Kafka server is running on 9092, right? So we have to use hyphen hyphen bootstrap hyphen server. Here we have to mention which port number it is running. So it is running on localhost colon 9092, right? So here I just so like inside topic there are three partition is there. We can create multiple partition, but in this picture I created three partition, right? So while we will creating the topic, we have to mention the partition also, how many partition we want. So I need suppose three partition, then hyphen partition 3. Then one more property we can use like hyphen replication factor. So this is, let's say, 1. This replication factor says that like how many copies of our data we want. So this is the command we can create our topic. So just hit enter. Yeah, maybe it has some issue. What's the issue? So missing required argument topic. Okay, here instead of create my log, here we have to mention the topic also. Hyphen create, then hyphen topic. Okay, just hit enter. Yeah, now topic has created. So if you want to know like how many topics has created inside the Kafka, then we can use the command bin slash Kafka hyphen topics.sh. Then we have to mention hyphen list. It will list out all the Kafka topic. So it will list out all the topics inside the Kafka. Then we have to mention like where our Kafka server is running, right? Hyphen bootstrap server is running on localhost colon 9092. Okay, just hit enter. So this is the topic just now we created my log. So now topic has created and inside topic partition also created. Now we have to publish the message and consumes the message. So who will publish the message? Publisher, right? So publisher can be anything. Publisher can be a Spring Boot application. Publisher can be a like your different Kafka, or publisher can be a database, anything. Similarly consumer also. So but here will use the Kafka publisher here. So I have already opened this two terminal. I will open one more terminal for publishing the message. So go to here and just new terminal at folder. So here I'll publish the message. To publish the message, we can use bin slash Kafka hyphen console. Okay, so this is producer. Yeah, producer.sh. Then space. So I'll produce the message, right? And I'll produce the message to which topic? My log topic. So we have to mention the topic name, then hyphen topic my log. Then we have to mention like where our Kafka server is running. So hyphen bootstrap hyphen server running on localhost colon 9092. That's it. Just hit enter. Okay, there is some problem. Bin slash Kafka console producer consumer hyphen topic my log hyphen bootstrap. Okay, this is bootstrap. So we have to make it as strap bootstrap. So again it's just clear the console. Okay, why again it is giving error localhost 9092. Okay, this is bootstrap. Sorry, my bad. This is bootstrap server. Okay. Yeah, now it is connected to producer application. So I'll produce the application here. Suppose my first log details. Okay, I just produce. So this is one message I just produce now into Kafka topic here, and now I'll consume the message, right? So I'll open one more terminal and this will consume the message. Don't confuse here because I just opened 4 terminal here. So this is, so one terminal I have run the Zookeeper, in one terminal I have run the Kafka server, in one terminal this is my publisher. He will publish the message, and this is my consumer. He will consume the message. To consume the message from the topic, the command is like bin slash similarly Kafka uh, Kafka console, then consumer, yeah, consumer.sh, then hyphen topic. So from which topic I have to consumer, we have to mention. So hyphen topic, my log, then hyphen bootstrap. Server is running on localhost colon 9092. Just hit enter. And here, if I'll send something, let's say hello world, just hit enter, here it will come. Yeah, hello world come. But if you see properly, observe here, I have sent my first log details message into Kafka topic, but here consumer will not consume. Why? So by default, when I will run the consumer, then if the publisher will publish the message, the new message will consumes, but I want the old message also consumed by the consumer. So in that cases, what you will do, control C, just run the same command with, we have to use one property called hyphen from beginning, so it will read the message from the beginning of the topic. So just hit enter. Yeah, now it came my first log details and hello world. So this is my consumer, right? And this is my publisher. If I'll publish, this is second message, hit enter, the consumer will automatically consumes the message, right? So in this way we can configure the Kafka, and we can publish the message to the Kafka topic, and the consumer will consumes the message from the Kafka. So this is the overview of the Kafka. So in the next video, actually I'll explain what is publisher, what is partition. In the first video I already said, like there are different terminologies there inside topic, like offset, partition. So I'll explain all these things. Then after explaining all these things, I'll create the Spring Boot application, how we can integrate our Kafka in Spring Boot application, and how we can publish the message to Kafka through the Spring Boot, and how we can consume the message from Kafka topic using the Spring Boot. I'll explain that also. So please stay tuned in my channel and subscribe if you not subscribed yet, and share more and more. Thank you everyone. Hello everyone, welcome to my channel Coding Care. So this is the third video of my Kafka series. In this video, I'll explain all the components of Kafka, like what is Kafka broker, and what is Zookeeper, what is Kafka cluster, and what is topic, producer, consumer. All these components I'll explain in this video. Please stay tuned and subscribe my channel. So let's get started. So before moving, I just remind you to the architecture of the Kafka. So here, so in the first video I have explained the architecture of the Kafka. So if you do not have watched my video yet, please go through once and watch it. So here different producer is there, and producer will produce the message, and different consumers will consume the message, and there produce the message to the Kafka broker, and all the Kafka broker is inside the Kafka cluster, and here Zookeeper is there. So what is this? I'll explain one by one. Before understanding all these things, let's explain with a simple example. For example, fast food center, okay? Let's say McDonald. So think that the Kafka cluster is nothing but the whole McDonald company, okay? And the company has many outlets across the country working together to serve the customer quickly, right? So suppose in our area one branches is there. So one branches is nothing but one Kafka broker. Okay, so the Kafka cluster is nothing but a just group of restaurant, okay, or group of brokers working as one team. Then second thing is Kafka broker. So I just said Kafka broker is nothing but one restaurant. Okay, so what it can do? So what's the purpose of the restaurant? It takes the customer orders, okay, then it prepares the food and it delivers the food to the customer. Okay, so think that Kafka broker is nothing but a one restaurant which is receives the message and stores the message, and whoever wants to consume the message, he will send the message. So this is the purpose of the Kafka broker. So what is Zookeeper? So Zookeeper is nothing but like think that it's a head office manager. So it's like a headquarter or central manager who will manage all these things. All these things means it will gives the list of all the working outlets, and it if one outlet goes down, then it reassign work to others, and it helps the coordinate foods delivery and team management. So all these things will managed by Zookeeper. So here Zookeeper is one of the manager who can manage the Kafka broker. Okay, which broker has down and which broker is up. If one broker down, then he will do some other things. I'll explain what he will do. Okay, I hope this example gives a little brief idea about the Zookeeper, Kafka broker, and the Kafka cluster. Okay, so I'll explain on later how the Zookeeper helps here to manage all these things. Okay, so if one Kafka broker is down, how it manages all these things, I'll explain later. But before the explain all these things, we have to understand what is Kafka topic, then partition. All these things we have to understand. Okay, now I have already created one topic. So here just open one terminal. So what's the command to see the topic name? So we can use bin slash Kafka topic, then hyphen hyphen list, then it is bootstrap server hyphen hyphen bootstrap server, which is running on localhost colon 9092 enter. Here my log topic I have created before. So here this picture says that publisher will publish the message to the topic and consumer will consume the message from topic. But actually we are sending the message. Okay, so if you'll see here, I just open two more terminal to publish some message and consume some message. So here bin slash Kafka hyphen console, yeah, producer, then so hyphen hyphen topic my log, then hyphen hyphen bootstrap server, it is running on localhost colon 9092 enter. So here if I'll send some message, then consumer will consume some message. Okay, so I'll create one more, I'll open one more terminal here. So bin slash Kafka console, then consumer, then hyphen hyphen topic slash my log, then hyphen hyphen bootstrap server, which is running on localhost colon 9092 from beginning. Hit enter. Okay, now it reads the message. Suppose here I'll publish some message. Let's say send some data. Okay, here consumer consumes the message, but actually this is a message we are sending here. Okay, but this is not a message, this is called event. So what is event? So many people knows that we are sending the message to the topic and we are consumes the message from the topic, but actually we are sending one event. Okay, an event have value. This value is nothing but this message. Okay, so what is event? Event is nothing but a something happened. So whenever we will send something or whenever we will publish something, then one event will trigger. So one event we are sending to the Kafka topic. So one event have content like event key, event value, and event timestamp, and some other metadata. Okay, so here we are sending message means we are not sending a message, we are sending an event. So one event contains these things. Okay, suppose I am sending some data here, some send some data, this is a message, right? So this is the event value. Then what is the event key? Event key is null here because we are not passing any key. So why the key is important, I'll explain later, but just think that here event has these many things is there. So how we can ensure whatever I am sending, this is an event. Okay, so let's do one thing. In consumer, what I'll do, I just control C, and if I want to see the proper event, then we can use some different command. Okay, bin slash Kafka console consumer dot sh, then hyphen hyphen topic. So this is my log. Then we need to mention the server, bootstrap hyphen server, which is running on localhost colon 9092. Then from beginning, then we'll use one property called hyphen hyphen property print dot key equal to true. Okay, this print dot key equal to true means it will print the key. Next, one more property called hyphen hyphen property, okay, print dot value equal to true. It will print the value also. Again, one more property called print dot timestamp equal to true. So here it will fetch the data from this topic, and which is running on this server. Kafka broker is running on this server. It will read the data from beginning, and these three property I am using to check an event: key, value, and timestamp. Just copy this one and paste it here. This is my Kafka consumer. Just paste it, hit enter. Now see, now my first log details. So this is the value, this is the timestamp, and this is the key. So here we are sending the data. Suppose I am sending some message or trigger an event, hit enter. Then here it came trigger an event. This is a value, event value, and this is a event key, and this is a timestamp. Okay, now you understand what is event. And by default the event key is null, so we can pass the event key also. So how we can pass the event key? I just wanted to event key as well as event value. So here we can just modify this this command, like, so this is my producer command. Here we have to just mention the property, hyphen hyphen property. We have to use parse dot key equal to true, and one more property, hyphen hyphen property inside double quote key dot separator. Okay, this separator equal to, suppose it's a colon. So what it will do, property parse key equal to true means we have to pass the parse dot key means we have to pass the value like key and value, which is separated with colon. Like first we have to write like something 1 colon some message, like this we have to pass the value. So just copy this one and paste it here. Okay, hit enter. Command not found. Why? Let's clear all these things, and okay, let's check this in Kafka producer topic, this one server, this one property key true, and the separator is colon. Okay, maybe this one will not required. We just copy this bin. Okay, so here paste it, hit enter. Yeah, now the publisher is ready to publish the value. Okay, so here while, so here when we are sending the message, how we can send, like 1 colon some event trigger. Okay, hit enter. Now here see 1 some event trigger. That means 1 is the key, event key, and this is the event value. So I hope this is clear now, what is an event and what is an event key and what is event value. Now we have to understand what is the purpose of the event key. So here interviewer will ask one question. Which question? Suppose this is my topic, okay, and I have 3 partition 1, partition 2, and partition 3. Suppose publisher publish some message like for we have a employee list, and employee have different department is there, like HR department, dev department, some other department is there, right? So one publisher will publish one event, okay, then it will goes to either partition 1 or 2 or 3, okay, and again one more event will send, again it will go to either this one or this one or this one, again one more event will come, again it will go to either partition 1, 2 or 3. But while consumer will consumes the message, there is no order, right? So some of the event will present here, and some of the event will present here, and some of the event will present here. Let's say there are different consumer is there. Let's say one consumer here, this is consumer 2, and one more consumer here, consumer 3. So here three different consumer is there, okay. So three different consumer consumes the message, okay, and all this consumer is part of the one consumer group. I'll explain what is consumer group. Just think that this all these consumers are part of one consumer group, okay. Now one consumer consumes the event from the partition 1, then that particular event will not be consumed by the consumer. But in the first video I explained multiple consumer can consumes the message, right? But wait, multiple consumer can consumes the message, but it should be a part of different consumer group, okay. So this is one consumer group, and suppose one more consumer group is there, and inside that multiple consumer is there, they can consume the same message, but in one consumer group only one consumer can consume one message, and the same message cannot consumed by the consumer 2, okay, clear? Now here different event is there, and at a time multiple consumer can consumes the different message, okay. But here interviewer will ask, like, all the events whatever the employee details will come, I want to process the HR department object in a order, in a order, okay. All the HR department event I wanted to process in an order. So in that cases what we can do, because publisher will publish the message, suppose one event come, okay, here one event come, this is one event, and let's say this event is a event is nothing but one employee object, okay. One employee object came, and this employee have a department is HR, okay. Now this event is go to partition 1. Now one more event came, okay, I mean one more employee object came, this is also a HR department, and it goes to partition 2, but this goes to partition 1. Just think that here this is HR department, this is also HR department, but these both objects are goes to different partition. If they go to different partition, then the multiple consumer can consume at a time, right? So this consumer consume this message, and this consumer 2 consumes the message from partition 2 at the same time, and the process simultaneously. So how we can overcome this problem? That's why key comes to picture. So same key we have to pass in one partition, so that always the object will be processed in sequentially. Suppose here key is department ID, department name, okay. So what I'll do, I'll pass the HR department as a key, like here, like HR colon then employee object, okay, employee object I'll pass. That means always it will go to the partition 1, it will never go to the partition 2 or 3. So if it will not go to partition 2 and 3, it always go to the partition 1, then obviously the first message will consumes, this is a queue, right? First one message will process, then second message, then third message, like that, okay. That's why key comes to picture. So this is the basic interview question. asked by the interviewer. In the next video, I'll explain what is consumer group, and you know already consumer and publisher. So publisher is nothing but any type of application, and consumer also same, any type of application. But in the next video, I'll explain the topic internals, how the message is storing and how it processing and how it's replicate all these things. I'll explain on the next video. So, but this one is very important and it will asked by the interviewer definitely. So thank you guys. Please stay tuned with my channel so that in next video I'll upload, you will get the notification. Thank you everyone. Hello everyone, welcome to my channel Coding Care. This is the fourth video of my Kafka series. So in this video, I'll explain all the core concept of Kafka. So what is topic, what is partition, what is offset, how partition is calculated, all these things I'll explain one by one here. And before watching this video, please subscribe my channel and share to everyone, whoever really wants. Let's get started. So first of all, we have to know what is topic. So in my previous video, I have already said like topic is something where we can store the data, right? So assume that topic is nothing but a folder in your system. Suppose in your system you have a folder, right? And similarly, this topic is kind of folder in your system. And topic name, we can write anything. Okay, suppose I want to tweet something in Twitter, then I can create the topic name as Twitter tweet. Then car GPS, then purchase. Topic name can be anything. Then second thing is Kafka topic supports various formats of message. Various format of message means it can store JSON data, or it can store Avro file, or it can store text file, or it can also store the binary file, and so more it can store. Now question is how the data will store inside topic, because topic is nothing but a folder. Okay, so inside a folder, how we can store the data or how we can organize. So that's why partition comes to picture. So what is partition? Partition is nothing but a, we can say it is a subfolder. Okay, so this is a folder, let's say this is a folder, and this is a subfolder inside this topic. This is one folder and this is one folder. Okay, and this is nothing but a partition. So inside topic, multiple partition we can create. I mean inside one folder you can create multiple folder, correct? Similarly here also inside topic we can create multiple partition. This is partition. Okay, now go to this picture. So here this is a storage system, this is a file system. Basically Kafka uses the file system for storing the data, and this area is called topic. So this is nothing but one folder, and this p1 p2 p3 is nothing but a partition. So inside a topic we can create multiple partition, but now I have assume that I have created three partition only. So partition 1, partition 2 and partition 3. There are three partition is there, that means three subfolder is there. Okay, and two different client is there. So this is a producer and this is also a producer. Two different producer client is there, and these two different producer client producing the message or producing the event into the topics. So this client sends that event to the partition 1 and partition 2, and this one sending the events to the partition 2 or partition 3. Now we have to understand how the partition organize the data. Okay, so whenever I will send one event, this event will append to one of the partition. I don't know which partition it will store, but it will append in one of the partition. But where it will append, that will decided by the partition number. Okay, so I'll explain. So this video, so I just explain here what is topic, then I'm explaining what is partition. So then I'll explain what is offset, then I'll explain how partition will be calculated. So here when I'll send one event, this event will append to one of the partition, and it will append at last, not at first. Okay, suppose I sent one message or one publishing one event. Suppose this event will come here, this area. Okay, now one more event can, now this one more event will append this area, okay, this area. So every time one event will come and the event will store in one partition, okay, clear. Now if I'll send the event with same key, then it will always go to the same partition. So in my previous video I have already explained how the Kafka ensure the ordering, okay. So please go through the ones on my previous video, then come back here, so it is easy to understand for you. Now we cover what is topic, what is partition. Now go to the next, okay. So just now I said topic is nothing but one folder and partition is nothing but one subfolder. So inside folder we can't store the data directly, right? We need file. Inside file we can store data. Inside folder how we can store the data? It's not possible, right? So similarly here inside the partition one file is there called log file, and in that log file when we will publishing one event, that event is stored into that log file. So this is the log file. So if you'll go here, this is recent, go to folder, this is temporary, and this Kafka logs. So here I have created the topic name as my log, and I have created three partition 0, 1, 2, right? So here three folder created, my log 0, my log 1, my log 2. That means three partition created. So if I open one of the partition, see one log file is created. So in this log file, if you open this log file, it's a binary format. So this is the file where our data will be stored, okay. So this is the binary file, we cannot see like it's a dot class file. So in Java like a dot class file, similarly this one also. So here actually whenever we are sending one message, this message will append here, okay, at last. So this is the file where our data will be stored. Now it's clear, right? So inside topic one log file will be created, and in that log file our message will be stored. Now the question is, suppose this file contains 1 GB of data, and once the 1 GB will be full, then if I'll send a new message, then where it will be stored? So that's why multiple log file will be created. So this is called segment. So there are multiple segment will be created, and each of the segment has like for example 1 GB of capacity kind of thing. Now go to the next component. So as I said, when the data will come or when the message will come, the message will goes to one of the partition, and inside the partition log file is there, and inside the log file one message will be appended. So if I not send any key, then Kafka sends this message as a round robin way. So if I'll provide the key, then the Kafka will send this message to a specific partition. Now how the Kafka know this message will go to this partition or this partition or this partition? The Kafka will calculate the partition number. How it will calculate it? So this is calculated like, so let's say this is partition equal to, so key hash of key. First it will calculate the hash of key, then percentile with number of partition. Now suppose key is something, let's say ABC, okay, and the hash of ABC, let's say 1 2 3, okay, and here 1 2 3 percentile by 3, how much? 0, right? So that means it will go to the partition number 0. Like that it will be calculated the partition number. Suppose I'll send one message, suppose hello world, and the key is let's say 1 colon hello world. Now this hello world will go to which partition? So first I'll calculate the hash of the key. The hash of the key, let's say 1, let's say this is 1, and let's say this is 1, and 1 percentile 3 equal to how much? This is 1, right? So it will go to the partition number 1, this one. So let's say this is P0 and this is P1 and this is P2. Now each message in a partition receives one unique identifier called id, okay, and which starts at 0 and increment with new messages. Suppose first message came and the, let's say the id is 0. Now I'll send one more message, let's say. So I'll pass one more message here, and this is, let's say again this is 1, and I am passing hello world to something. Now this message will come, and here it will store, right? Again first hello world come, then hello world 2 came. Now the now this id becomes, let's say 0, then 1, okay. Then again if one more message will come, then it will become 3, then it will increase, so on. If one new message will come, then it will increases the id. This id is nothing but offset. So now I hope you cleared what is offset in Kafka. But how this offset help us while we are consuming the data, I'll explain later. So before that, I have to explain this partition and distributed, all these things, okay. So we covered topic, partition, offset, and how partition calculated. Now how Kafka ensure order guarantee. This one already I have explained in my previous video. Please go to my previous video once and watch first, then come back here. Then you can easily understand all these things. Then next is how partition are distributed, okay. Now for assume I have one Kafka broker, and in one Kafka broker we have created 3 partition and one replication factor. So while we create the topic, we have to mention the partition as well as the replication factor, right? So this partition 3 means inside one broker I have created one topic, this is my log, and I have created 3 partition. That means inside this my log folder there are 3 subfolder will be created, and in that subfolder my message will be stored. Here replication factor 1 means only one copy of our partition will be there. Suppose I will mention 3, that means we have to, replication factor 3 means suppose I have 3 broker and each partition has 3 copy, and in each of the broker, okay. Suppose I have a 3 broker here, for example in this picture I have 3 broker 101, 102 and 103. So replication factor 3 means in each of the broker all this partition will be available, 3 copy of my partition. Like suppose this is broker 102, and in this broker partition 012 is there, and this in this broker also this partition 012 is there, and in this broker this partition 012 is there, okay. So here I just expand the partition 0 only. So this is a, for example there are 3 broker, and out of the 3 broker Zookeeper will decide who is the leader and who is the follower. Leader means who will lead, and the follower means they automatically copy or clone the data from the leader, okay. Suppose I will send some message and the message will go to the leader, not a follower, okay. And while consumer will consumes the message, it will consumes the message from the leader, not the follower. Follower only saves the copy of the message, okay. So this partition 0, so let's say this is my leader, broker 101 is my leader, and this is offset 0123 means there are multiple messages is available inside my partition. Now once the message will be stored in partition, the follower will automatically replicate from the leader. So my data is not only stored in one broker, my data is stored in different broker, okay. So if the leader will fails, or it will fail to serve the message, then from these 2 follower one of the follower will become a leader. So that will decided by the Zookeeper, okay. So suppose I have 50 broker is there, and out of that 50 broker one leader and 49 follower is there. Suppose one leader fell, then what will do? So when I will send the message will go to the leader, but here leader has down or something, due to something it failed, then what will do? So Zookeeper has all the information, okay. So the Zookeeper will decide out of the 49 follower, who will be the leader? He will decide it. Then it will be then one new leader will come, then other 48 follower will be available. So in this how the leader and follower will work, and partition will be work, and the offset will work. So here I just explained here how partition are distributed across Kafka broker and what is leader and follower in Kafka. So whenever we are sending the message or event, the event will append into the leader partition, not follower partition. Okay, follower is nothing but only just it will store our copy of our data. That's it. Okay, if the leader fails to serve, then one of the followers become a leader. So this is the purpose of the follower. So mostly we covered all these key concept in Kafka. So if you have any doubt, please comment me in comment section. Then in next video I'll come up with on Spring Boot project how we are applying our Kafka. One small application will be created. In that application I will explain how our Kafka consumer and publisher is working. Okay, so please subscribe my channel and share it. Thank you. Hey everyone, welcome back to my channel Coding Care. So today's session is going to be completely hands-on, and in this video I'll create a small application, a real-time application, so where we can implement our Kafka producer and consumer. If you have not seen my all the video of my Kafka series, then please go through the ones and you can get all the theory knowledge from this video. So in this video I'll cover all the producer and consumer setup, topic creation, how we can send the message, or how we can do the real-time message processing, and much more. Okay, so please subscribe my channel and share it. So all the code available in my repo, I have given the link in my description, so feel free to clone my repo, and by end of this video we will have a completely working Kafka project that you can use a reference on your own application. So let's get started without delay. So here I'll take one small use case where you can implement in your application. For example, assume that I am creating one e-commerce based application. So e-commerce based application, what we can do, suppose this is my e-commerce based application. Okay, e-commerce based application. So here suppose I am purchasing something, then what I'll do, I'll select my required product and add to cart, then I'll buy through my debit card or credit card or UPI. Then once the transaction successful, then we can get the order tracking information, right? So here what I will do, once the transaction will complete, all the transaction information log I'll send to the Kafka, so that the other application can receives or consumes my log. Okay, transaction related log. So here this is an e-commerce site I am creating, and here what I'll do, I'll doing some transaction here. Okay, once the transaction successful, so this is my Kafka topic. Let's say this is my topic, and once the transaction will successful, I'll produce the message to the Kafka topic, and different application will receives. So this is a consumer application. Okay, this consumer application will read or receives the data from the Kafka topic. So this is the basic thing we can implement now. So what I will do, I'll create one Spring Boot application. Okay, a new project. So this is transaction producer app. Okay, this is transaction producer app. So transaction details it will produce Maven project, then next. Now I'll add Spring Boot web, Spring web, then Kafka I have to web, this Spring for Apache Kafka, then I'm using Lombok. Okay, Lombok. Let's create the application. Yeah, Now my application is ready. So here I'll create different package. So this is controller package. In controller package I'll create a controller class. Let's say transaction controller. Okay, so here I'll add annotation rest controller. Okay, then I'll create one method public string create order. Okay, create order. So inside create order, what I'll do, I'll read the order information as well as the payment information, and I'll write the business logic. Once the transaction will successful, then the same transaction object I'll convert it to string and I'll pass to, or I'll produce to the Kafka topic. So here what I'll do, read card details and payment info. Okay, then write business logic for doing transaction. Okay, once the transaction successful, if transaction successful, then what I'll do, I'll convert this object, I mean transaction object, okay, into JSON. Then I will send this JSON, okay, or I'll produce this JSON into Kafka topic. But question is here we have to read the card details, then payment information, then writing business logic, then we'll do some transaction. Okay, so instead of doing all these stuffs, let's focus on Kafka thing. Okay, instead of doing all these stuffs, directly I'll send the transaction information through the postman. Okay, so I have already the transaction JSON. This is the transaction JSON. I'll pass this one. Let's create a different, okay, let's new HTTP request. This is post request body, okay, JSON. Let's send this transaction details directly. Okay, instead of writing business logic and creating the transaction object, let's send this transaction information directly. Okay, because we are focusing on Kafka, not the business logic here. Okay, so here we need to create the transaction object, an entity class, transaction object. Now let's copy these things. Okay, so transaction ID string private string transaction ID, okay, private string from account, from we just copy paste from account, okay, okay, to account, then amount is double. Okay, now timestamp, let's timestamp is local daytime, now transaction type, now currency status. We have a transaction entity class ready. Let's create getter and setter. We are using annotation data because we are using Lombok at the rate all are constructor at the rate no are constructor. Okay, entity class ready. Now I'll receive the transaction object. I'll use at the rate request body, okay, transaction. Now I can read this transaction object directly. After reading the transaction, what I'll do, I'll convert this into JSON. Okay, how I'll convert to JSON? I can use the object mapper here. So let's create the object mapper here. Object mapper, okay, object mapper, instead of creating object like this, okay, let's say this is private final object mapper. Okay, why it is giving error, not been initialized. Okay, we can initialize. Here we can do through the constructor injection, we can create the object for this object mapper. So transaction controller, okay, so here I can use that object mapper, this dot object mapper. Okay, through the constructor injection I am creating the object of this object mapper. Now here using object mapper, okay, dot write value as string. then we can pass this object, transaction object here, and once, so it then it will return the JSON data, right, string, it will return a string. Okay, so it will return a string. Okay, transaction info or transaction log. Okay, transaction log. Now what I'll do here, this transaction information. Okay, for example, let's our transaction is successfully. Okay, once the successfully, this transaction object will create. Okay, for now I am reading this transaction object from Postman, but actually this transaction will object will create after business logic will executed. Okay, so now this transaction object I converted to string, and this value or this string I'll pass or I'll send to this Kafka topic. So let's see how we can send the message to the topic. So first of all, what we can do, we have to configure the Kafka related things. Okay, where the Kafka is running, which port number it is running, what is the host, all these things we have to configure. So let's create one Java class Kafka config. Okay, so first of all, we have not created the topic yet. Either you can create the topic through the command line or through the Java also we can create. So make it as @configuration class. Okay, so how we can create the topic? So here public new topic. Okay, this is, that's a topic. So return new topic. Okay, so here we have to mention the topic name. Okay, so let's say that topic name is transaction producer topic. Okay, and how many partition you want? Suppose I want 3 partition, and this one is nothing but replication factor. Okay, so make it as bin. Now what I'll do, I'll configure the Kafka related information. So whatever will send the data. Okay, for example, in JDBC, how you are sending our data to the database, we have to create the connection object. Through the connection object we are sending the data, right? So here also same kind of thing, we have to create the Kafka template. Through the Kafka template we can send the message. So how we can create the Kafka template? Public Kafka template, and this is key value pair we have to mention. So I'm using string Kafka template. Here return new Kafka template, and inside this constructor we have to pass the factory class. Okay, here we have to pass the factory. So inside this factory, I mean producer factory, so inside this factory we have to mention like where our Kafka is running, and what is the serialization we are using. Okay, so when we are sending the data, actually it is using serialization, and when we will consume the data we are using some deserialization. So we have to mention all these things. Okay, so here first of all we will create the object of factory. Okay, public, and producer factory. Yeah, this one, producer factory, and this is string producer factory. Now we'll create the map object, and here we have to set all the property here in map. Then I'll set all this information inside that map, and I'll pass this map to this factory class, and same factory I'll pass to Kafka template. So here config, okay, configs.put. So not this bootstrap server, instead of it have producer config. Okay, something is there, producer is this one, producer config dot, so many property is there. So we have to use the server. So bootstrap server, yes, this one, bootstrap server config. That means our Kafka is running on localhost 9092. Okay, now config, yeah, dot port producer configure key serializer. Okay, key serializer means when we will produce the message or produce the event, we have to mention like how our key will serialize and how our value also serialize. Okay, so I am mentioning my key will serialize as a string serializer. Okay, so make it as import, yes, Apache one, then value serializer. So instead of string serializer I am using json serializer. json, one second, json serializer, yes, this one. Okay, this is yes, Kafka one. Okay, dot class. Okay, now this property I'll pass to here, new default Kafka producer factory, and I'll pass this config to the this object. Now this one I'll pass here. Now make it as bin at the rate bin. This also make it as at the rate bin. So this property we can also configure in properties file, but here I have configured. Now all this Kafka related configuration is ready. So here I'll import this one. Okay, I'll import this Kafka template object in controller and I'll send the message. How I can do here, Kafka template. Okay, Kafka template. Okay, here make it as string. Now make it as at the rate auto add. Okay, through the constructor injection also you can do, so it's better to pass in constructor injection. Okay, so here this dot Kafka template equal to Kafka template. So I am removing this part. Okay, sorry, only this one. Make it as private final. Okay, now Kafka template is ready. Here Kafka template dot send. So in send, what we need to pass, we have to pass the topic name here. So let's say topic name is, make it as here string topic name. Okay, what is the topic name we have configured here? Topic name is transaction producer topic. Okay, same topic name we have to pass here. Make it as final. Okay, so here pass topic name comma this transaction log. Okay, now return, instead of transaction log return transaction log successfully sent to topic, this topic name. Now let's run this application. Yes, now the transaction, okay, now application is running, but thing is admin client, okay, localhost could not be established, so node may not be available, so we have to run the Zookeeper. Okay, so I have already installed in my system. So yeah, this is the thing. So you have to install this Kafka. Okay, so Kafka zip you can install, then you can unzip here. So here I just open the terminal and copy the path. Okay, cd, I'll go to this particular path and first I'll run the Zookeeper. So for running the Zookeeper I have already this command. So all this command I have already given in my description. Okay, so here just paste it. Okay, now Zookeeper started. Now one more terminal I'll open and here I'll run the Kafka server. So this is the command. Okay, okay, now Kafka has started. Okay, so if you'll go here, okay, see, started transaction producer application. Now there is no exception. So I'll go to the postman, and I've already these details, and I'll pass this one localhost instead of transaction. What I have given, oh my bad, this one we have to give @ post mapping, and we have to pass, let's say, slash transaction. Okay, same thing we have to pass here. Okay, now send the request. See, transaction log successfully sent to topic. So now the successfully this transaction details goes to this topic. Okay, but check whether is already goes or not. So here create a new more tab, and for checking the message from the topic, you can use this command. So this is the command, just paste it. Okay, we have to use the topic name. So what is our topic name? Our topic name is transaction producer topic. So here this is the topic we need to use. Copy this one and here paste it. Okay, see, this is the message we have sent. Now we will create one more application, which is consumer application, and we will consume the same message. Okay, same message from this topic. But before consuming the message from this topic, if you see properly, okay, in Kafka config, while I creating this topic, I had mentioned partition 3. So when I send this message sent to partition 0. So there are 3 partition 0, 1, 2, but this message is going to partition 0. Okay, and this is nothing but key. If you have already watched my previous video, then you can understand what is event key and what is event value. This is event key and this is event value. So event key is null, but I want to pass the event value with event key. So here what we can do, we can pass the direct here. Here if I'll mention some key tr-1. Okay, so this is my key. I just rerun my application and I'll send here. So if you'll check here, see, this is tr-1, this is key and this is value. Now this is goes to partition 2. Previous message go to partition 0. This message go to partition 0. But if you'll observe properly, we don't have control of the partition. Okay, I want like suppose we are passing the card type. Okay, sorry, transaction type. So there are different transaction type is there. Let's say this is a credit card, debit card, or UPI. Okay, so I want, if the transaction type is credit card, then it should goes to where? Partition 0. If the debit card is the transaction type, then it is goes to partition 1. Then if the UPI is the transaction type, then it will go to partition 2. Okay, this kind of logic I want to implement. So we have the control of our partition, right? So here we don't have the control of our partition. Any message is going to any partition. Okay, if I want to process something in order, what I will do? I have to pass the same partition. Okay, so how it is possible? So here what we will do, here I will create one class. Okay, here I will create the config class. Okay, let's say transaction type partitioner. Okay, so this class is implements from partitioner. Okay, yes, this one. Now override all the method. Okay, so in this method, this partition method, we have to write the logic. So this string s is nothing but our topic name, and this object 1 means this is a key. So when I'll pass the data, okay, I have to pass the key, right? So based on the key, I'll decide the partition number. If you have already watched my video, I have explained how the partition is calculated. Like it will hash of the key, then percentile by the partition number, right? So similarly, hash of the key. So this is nothing but key. So based on the key, we have to pass the key. Okay, based on the key, it will calculate the partition. So here what I will do, instead of return 0, okay, So here what I will do, suppose I will pass the transaction type as a key. Either UPI will come or credit card will come or debit card will come. Okay, this is the key transaction type. So here I am using switch if key object, okay, key object, then what will happen? So case 1, in case suppose UPI will come, okay, if UPI will come, then I will return 1 percentile partition. How I will get the partition? From this cluster, okay, from this cluster, okay. So here cluster dot is partition count, okay, for topic, partition count for topic, and we have to pass the topic here, okay. Instead of writing here, make it as local variable, and this will return end partition, okay. Now this partition I will mention here, okay. So 1 percentile partition means 1 percentile 3, so it will always return 1, right? 1 percentile partition will return 1. Now in the case of credit card, okay, credit card, in the case of credit card, okay, it will return 2 percentile partition, that means it will return 2. In the case of debit card, okay, I just copy paste, debit card, it will return 0. So 3 percentile 3 is 0. Now default is return 0, okay. Why it is giving error? Incompatible type, okay. So this key object I will convert it to string, okay. Here string key equal to string dot value of key object, then I will pass key here, okay. So now this class is ready, but this class I have to register, okay. So how I will register this one? In this Kafka config, here we need to pass one more properties, config dot put producer config dot. So this is something key serializer, automatic batch, buffer client, something partitioner, okay, partitioner, yes, this one, partitioner class config, and we have to pass the class name is transaction type partitioner dot class dot get name, okay. Now just rerun this application, okay. Okay, one more thing I just forgot. So here we need to pass the key, okay. Instead of tr1 I have to pass the key as a this transaction type. So here I can do transaction dot get transaction type, yeah, it started. Now I'll send UPI, okay, send the request, okay. If UPI is there, then if it's UPI, then it will go to the partition 1. Let's check. See, this is go to partition 1. Now I'll pass the credit card, okay. So here I'll pass credit card. Let's check, it's partition 2. Now I'll check for debit card, okay. Now it's go to partition 0. For debit card it's 0. For default also it will go 0. Suppose, so I'll pass some net banking, send the request, it is go to 0. So in this way we can do partition, and we can pass the message to the particular partition, okay. Now in the next video I will create the consumer application, and in that application I will show you how we can consume this message, Okay, so this is the real-time scenario we can use in Kafka. So please go through my previous video once, so that is all this theory, so easily you can crack in an interview. Okay, and if you liked my video, please share and subscribe. Thank you. Hey everyone, welcome back to my channel Coding Here. So this is the final video of my Kafka series. So in this video I'll create one consumer application which can consume the message from the Kafka topic. So in my previous video I have explained how we can create a producer application and how we can produce the message or produce the transaction information log into our Kafka topic. So this is our last video of our Kafka series. Let's get started without delay. But before that, please share and subscribe my channel. So in the last video here I have created this transaction producer application. Okay, so this producer application, in transaction controller we are producing the transaction related information to our topic. So the topic name is this one, transaction producer topic. Okay, so now we'll create one more Spring Boot application project, and this is, let's say, transaction consumer app, and this is Maven project. Next, here I'll add the dependency for Spring Boot Web, then Kafka, right? Next, okay, this window, new window. Now, so here if you'll see my producer application, I have created one class, Kafka config class, and here I have configured all these things. So these things we can also configure in Spring Boot application.yaml file. So here I'll show you how we can configure in application.yaml file. So in the resource, here suppose server dot port 9090. Now we have to add the property. So here when we are producing the message, we are using producer config dot Kafka serializer, right? But when we will consumes the message, we have to deserialize, right? So we have to add the property for deserialize, Kafka key deserializer and Kafka value deserializer. Okay, and we have to mention where our server is running, Kafka server is running. These three things we need to add, right? So here in property file, spring dot Kafka dot, yes, bootstrap server. This is running on localhost colon 9092. Now we have to add the key deserializer, right? So spring dot Kafka dot something deserialize, yes, this one, spring dot Kafka consumer dot key serializer and value serializer. Okay, one more, spring dot Kafka dot consumer, okay, consumer dot value deserializer. I'll mention the key serializer as a string serializer, okay, and the value deserializer also I can mention the string serializer. Okay, so here we have to mention, we can mention the strings deserialization. So I also exactly not remember. So here Kafka consumer key deserialization. Okay, yeah, let's check which one. Okay, org, yes, this one, just copy this one, serialization dot, we need to use string serializer. Okay, string deserializer, string, this one, string deserializer. Okay, same value we will use for this value. Okay, Kafka value. Now the Kafka configuration is done. Okay, now second thing is we have to create one listener. Okay, so what the purpose of the listener? So when I'll publishing one event through the producer, once the producer will produce the event, then consumer will consume, right? So how it will consume? That's why one listener is there. So we'll create one listener for this one, and the listener will listen when the message will publishing to the topic. Immediately the Kafka listener will listen. Okay, so I'll create one package for this is listener package, and here I'll create one class. Let's say consumer consumer listener container. Okay, so here I'll make it as at the rate service. Now I'll create one method public void consume transaction log. Okay, so here the argument I can pass string message. Now this method will call by the listener, but how the Kafka knows this method will call? Okay, so we have to use one annotation called at the rate listener, something Kafka listener. Yes, this one Kafka listener, Kafka listener. So this listener will listen the particular message, but from which topic it will listen? So we have to mention the topic name as well as the consumer group ID. So here we have to mention the topic name first. Okay, so topics equal to what is that topic? This is okay, the topic name is this one, transaction producer topic. Okay, now I'll mention the topic name, then I'll mention the group ID. Group ID equal to, let's say this is transaction group ID. Okay, now when I'll publishing one event, this method will call. So here just normally we can print this out and MSG. Okay, let's check whether it's working properly or not. Just run the application. Yeah, it's run. Now I'll go to the postman. Okay, let's check whether my producer app is running or not. Yes, it's running. Okay, now go to the consumer app and I'll send the request. Yes, this is the request, right? I'll just send the request. Yes, log successfully sent to this topic. See here, this one, this system.out.println print this message. This transaction ID is something, this one, this one, this. So this is a string format we can get. So in this how we can get the message, or we can consume the message from the topic. Then after we can consume, suppose I want to store the data in our database. Okay, so then you can write the logic according to your business requirement, right? We can convert this message into object. We can use object mapper, and that same object we can store into our DB. So this is how Kafka consumer is working and Kafka producer is working. So finally I am ending my video for the Kafka series. So please, if you like my Kafka series, then share it more and more. So it will be very helpful for me. Yeah, thank you everyone.